PVD04 is located in Bay 2 inside the Quattro nanofab. To use the tool, you will need to complete the training for the tool, and to reserve the tool in the IRIS system. The tool can process any sample size up to 6 inches in diameter. Also, you must be in the lab at the tool while it's running. You may not leave the lab while the tool is running unless there's an emergency, such as a fire or toxic gas alarm. These materials are available in the tool and are kept stocked by staff: titanium, gold, chromium, and palladium. If you'd like to deposit other materials than these, please request training for these evaporators shown here, or these sputtering tools shown here. If you need any further help to decide on which tool to request training for, please contact staff at the email address shown here. This tool is interlocked through the mouse and keyboard. If it's not responsive, double-check to make sure that you are logged in through IRIS. Also, this tool has a touchscreen. You can use either the touchscreen or the keyboard. Just be careful not to select the wrong thing. Before proceeding, we need to check the crystal quality. To do this, click the Deposition tab at the top and check the crystal quality. The crystal quality should be at 30% or higher. If it's not, or there's a crystal error, please stop your run and report it as a problem through IRIS. You should be able to find this ring next to the tool. If not, try venting the load lock first, since the user before you may have left it inside the load lock. For any sample that's smaller than 6 inches in diameter, you'll want to mount your sample onto this platen. You should also be able to find this near the tool. If you're going to run your deposition on a 6-inch wafer, you can simply put your wafer inside of the chuck. If your sample is smaller than 6 inches, you can attach your sample to the platen. You can use the set of screws and clips in the tray nearby, or you can use Kapton tape. Now that our sample is mounted, let's vent the load lock. Click LL Vent to vent the load lock. As you use this tool, keep your eye on this recipe monitor box. It will always show you what step of a recipe you're on. The load lock is now vented. It's located back behind the computer interface, and you'll need to open the door and lift the lid to the load lock. Place your sample face down into the ring, and load it into the load lock. Close the load lock lid. And close the door. Click LL Pump and Load Sample to pump down the load lock and load the sample into the chamber. The recipe will prompt you to enter a sample ID. Click the Motion tab, go to LL Substrate ID, type something in, and hit Enter on the keyboard. It's critical to hit Enter on the keyboard, otherwise it does not register with the tool. Go back to the recipe monitor, click Resume, and wait for the recipe to finish. Now that our sample is loaded into the process chamber, we can run a recipe to deposit our metal. Click Run Recipe, and choose a recipe to deposit the metal that you'd like to deposit. Then click Run Recipe. The tool is programmed to work with deposition thicknesses in kilo-angstroms. Most of us don't think in kilo-angstroms, we think in units of nanometers. So to convert your thickness target from nanometers to kilo-angstroms, simply divide your thickness target by 100. Enter your thickness target in kilo-angstroms. Then hit Enter on the keyboard. Then click Continue Load, and the process will begin. Throughout the process, we should keep an eye on the deposition rate and the power being used by the tool. The chart will usually tell us what we need to know to diagnose and troubleshoot any problems that might arise during the process. You should see a chart down here on the Windows taskbar. Let's open it up like so. Sometimes the chart is not open when you come up to the tool. The previous user might have closed it, or the tool was rebooted, or something like that. To set up the chart, click Chart, Settings, Files, Import Saved Settings, Master eBeam Chart.ini, and Open. I usually like to make the chart a bit smaller. I also like to change the time range to 5 minutes, just a personal preference. To do that, click Settings, Parameters, change the time range, and click Apply. During this part of the process, the tool is warming up the metal to be deposited. We call this the ramp and soak phase. We ramp up the power and let the electron beam run over the material, or soak it, to warm it up. We ramp the power up again and soak at a higher power to finish warming it up. Then the control algorithm in the tool will adjust the eBeam output power to keep the deposition rate steady at 2 angstroms per second. As the process proceeds, you'll see these phases show up in the chart like so. You can also see the metal inside the chamber. Hold the shutter open like this, look down, and you'll see the metal. Some of the metals, especially titanium, will be very bright when you look at them, so this will damage your eyes if you don't have eye protection. Grab an eyepiece before you look inside the chamber. When the deposition is complete, you can run another process with a different metal if you'd like. You do not have to unload the sample first. For example, if you just deposited titanium, you may now run a gold deposition. If this is your last deposition on the sample, let's proceed. To unload your sample, run the sample unload recipe. Then run the load lock vent. Take out your sample and close the load lock. And run the load lock pump. Once the load lock pump is complete, you can log out of Iris. This work was performed at the Singh Center for Nanotechnology at the University of Pennsylvania, a member of the National Nanotechnology Coordinated Infrastructure (NNCI) network, which is supported by the National Science Foundation. Thank you.